Okay, here's sample problem 15.4. The following reactions have the indicated equilibrium constants at 100 degrees C. So they give us two reactions. The first one is 2NO-Br in equilibrium with 2NO and Br2, and they give us the value Kc, which is 0.014. Okay. The second one, the second reaction is Br2 plus Cl2 gives us 2 BrCl, and the Kc for that one is bigger, it's 7.2. Calculate the value of Kc for the following reactions at the same temperature. And again, temperature affects the value of K, so they got to do this at the same temperature. So let's try each one. Okay, so this is the issue that we can manipulate equilibrium constants through manipulation of the equation. So here's the idea. For part A, that is the reverse of equation 1. Everything that's a product in equation 1 is a reactant in A, and everything that's a reactant is a product in A. So A is just the reverse of 1. And what we said in the lecture is that if you reverse the equation, it's the reciprocal of K. So I'm going to call this Kc prime because it's not Kc. Kc is 0.014, so it's 1 over Kc. Right? You reverse the equation, you take 1 divided by the value of K. So this is 1 over 0.014. And so if you do that calculation, 1 divided by 0.014, you get a big number, right? So that's 71. Okay. Now in B, it looks like it's the same equation as 1. It's NOBr turns into NO plus Br2, but they've doubled everything. So instead of 2 NOBr, it's 4. And instead of 2NO, it's 4. And instead of Br2, it's 2 Br2. So they doubled everything. And so for that, when you multiply the equation by a number, you raise the value of K as an exponent. So you take that K and you raise it to that power. So since we multiplied it by 2, we raised the power of K to 2. If we had multiplied it by 3, we would raise it to the third power. So it's just squared. So it's just Kc squared. So this would be 0.014 squared. Now that's going to make it smaller. If you take 0.014 and you square it, you get 1.96. I guess it's around 2.0 times 10 to the minus 4. Okay? So the coefficient that you're multiplying by becomes an exponent. So part C, it looks like it's NOBr, so it's the same direction, NO and Br2, but now it looks like they divided it by 2 or multiplied it by half. Remember, dividing by 2 is the same as multiplying by a half. Okay, so they divided everything by 2, and that's the same as multiplying by half. So the same idea, Kc prime in this case would be Kc, but now you would raise it to the half. Now just mathematically, if you raise something to the half, that's the same thing as the square root. Okay, so it's really just the square root of 0.014. Okay, so square root of 0.014 is 0.12, 2 sig figs. Okay. Now let's take a look at D. D, wow. Now this one here has NOBr, but it also has Cl2. So it clearly has materials from both reactions 1 and 2. So if you look at it, it's 2 NOBr, so it hasn't changed the direction of reaction 1. That's still written in the same direction. And Cl2 is a reactant, so reaction 2 is written in the same direction. So they haven't reversed reaction 1 or 2. So it looks like they just added them. So if you just add them, Kc prime, oops, hold on a second here. Kc prime, when you add reactions, you multiply the equilibrium constants. Okay, so it looks like D is just the addition of those two reactions. Okay, so Kc prime is just going to be Kc1 times Kc2. Okay, so that would be 0.014 times 7.2. So 0.014 times 7.2, and that's 0.10. Okay. Last one, E. E has NO on the reactant side. So it looks like we reversed equation 1. And it also looks like, since there's only one NO there, it also looks like it was divided by 2, right? Okay. So it looks like equation 1 was reversed and divided by 2. Now, there is also BrCl in there. And that one, the BrCl, is a reactant, not a product. So it looks like it got reversed. And it looks like there's only one, so it looks like it was also divided by 2. So wow, they're doing all kinds of things. So they've done everything you can. They've taken equation 1, reversed it, and divided by 2. They've taken equation 2, they've reversed it, divided it by 2, and then they've added the 2 together once they did that. So we're taking all of the different rules here together. So it looks like for equation 1, we're going to reverse it, and then we're also going to divide by 2, so take the square root. So it looks like it's 1 over the square root of Kc1, and then we're going to multiply that by 1 over the square root of Kc2. Why? Because you're reversing each one, so that's the reciprocal. You're dividing by 2, so that's the square root, and then you're adding them together. Okay, so I can actually write this a little bit more simply. It's Kc1 times Kc2, 1 divided by the square root of that. So that would be 1 over the square root of 0.014 times 7.2. So let's try that. This is 0.014 times 7.2 is 0.1008. We're going to take the square root of that and then the reciprocal. So 1 divided by the square root of 0.1008. And so that looks like it's about 3.1. Okay. All right, there you go. All of them put together there.